quiz, and I wanted to go through the complex empirical formula determination problem. So let's take a look here and see what we've got. We've got another combustion reaction. Notice again, hydrocarbon with oxygen, oxygen gas. We're going to completely combust this and produce carbon dioxide and water, so a famous combustion reaction. Notice we're not sure of the empirical formula of this compound, so that's the whole point of this question, is to determine what the subscripts are for this. Notice we can easily determine the mass on a balance, and notice we've got 4 sig figs there. Let's combust it in excess oxygen gas. Let's collect the carbon dioxide, and let's collect the water. What we need to do is to determine the mass of the carbon in that total mass of the compound. We need to determine the mass of the hydrogen in that total compound. And then we need to determine the mass of the oxygen in that compound. Once we know the mass that's present in this total amount of each of these elements, then we're in familiar ground. We can convert the grams of the carbon to moles. We can convert the grams of the hydrogen to moles, the grams of the oxygen to moles, divide by the smallest molar quantity, and then we should be pretty close to being finished, or we will be finished at that point. Now we need to be careful here. There's oxygen that's reacting that is not part of this original compound, so that's important. Notice oxygen from here and here could have come from this source or could have come from that source. We're just not sure. So what we want to do here is figure out the mass of the carbon, then we'll figure out the mass of the hydrogen, and then we'll use this mass plus x equals the total mass. Easily we'll solve for x, and then we'll get our 3 mass quantities of those elements, and then we're on our way to solving this fairly easily. Okay, so I want to determine the mass of the carbon in the carbon dioxide because that mass has to equal the mass in our original unknown sample. 2 ways to do it. One way would be I'm starting with this many grams of carbon dioxide that I've collected from the experiment, and from this I can do a dimensional analysis, or what I refer to as setup and cancel, and just do conversions all the way till I eventually figure out the mass of the carbon in this amount of carbon dioxide. I've taken the liberty to get this going here. I've got this many grams of CO2. Let's times all this out. Notice my grams of CO2 cancels, and now I'm at moles of CO2. I know that for every 1 mole of CO2, there's going to be 1 mole of carbon present. Next, for every 1 mole of carbon, I have 12.01 grams. Well, let's cancel. And notice I'm left with grams of carbon, and I have 2.002 grams of carbon. We can write that over here because they are equal. Next, let's figure out the mass of the hydrogen in the water, which of course is going to be equal to the mass of the hydrogen in that unknown sample. I've got 4.50 grams of water. How many grams is the hydrogen contributing to in that total mass? Let's find out. So 4.50 grams of H2O. Let's convert that to moles. So we've got 18.00 grams of H2O per 1 mole of H2O. Be systematic and show your work clearly. Let's go from moles of H2O, I know that for every 1 mole of H2O, I'm going to have, and here's what's important, mistake from a few people on their quiz test quiz, whatever we want to call it. Notice for every 1 mole of H2O, there are 2 moles of hydrogen. Notice that relationship. For every 1 mole, there are 2 moles. Just look at the chemical formula. 2 moles of hydrogen are combining with 1 mole of oxygen to make 1 mole of water. We also know that we have 1 mole of hydrogen. It is 1.008 grams of hydrogen. Let's calculate that quickly. I'll do it kind of quickly, so 4.5. And I'm left here with 0.504 grams of hydrogen. Let's cancel. And there we go. That's my mass of hydrogen in that amount of water, which is equal to the mass here. Next, I know mass of carbon, mass of hydrogen. I don't know mass of oxygen, but I know the total mass, so I can quickly figure out the total mass. And by some simple algebra, I've determined the mass of the oxygen. This mass plus x equals that, and I just solve for x. And I have 1.327 grams. We are almost finished solving this. Let's do the last step. We have almost completed this problem. Notice we have the mass quantities in that original mass. And notice what I've done here. I've converted the gram quantities of the carbon, hydrogen, and oxygen to mole quantities. And there they are. Notice I'm not using diatomic O2 for molecular mass. I'm using oxygen. We're dealing with oxygen here. So we're not dealing with the diatomic. So it's not 32 grams per mole. Same way with the hydrogen, it is, notice the hydrogen is not diatomic. In this case, obviously, take a look. Well, here are the molar quantities. Our last step is to divide by the smallest molar quantity. Notice that I've divided by the smallest molar quantity, and here we go. So there's our oxygen, there's our hydrogen, there's our carbon. So these are the moles of carbon, moles of, I didn't write moles there, but it is 6 moles H, 1 mole O. Let's go back to the original. Now, here we go. Hello back there. And here is our final empirical formula. There it is. Now we could balance this whole reaction. Unbalance now. So we've just determined something really important. Well, before I leave you, and I hate to leave you, parting is such sweet sorrow, I wanted to show you that there is another way to figure out the mass of the carbon in the carbon dioxide. Here certainly is one way. So we have 2.002 grams of carbon in this amount of the carbon dioxide. Notice, here's my CO2. I can get this value another way. I know that my percent by mass of carbon and carbon dioxide is given by this. So you have 12.01 grams per mole of carbon divided by 44.00 grams per mole of CO2 times by 100% gets us 27.3%. That's 27.3% of carbon by mass. Well, all I need to do is figure out what 27.3% of 7.333 is. Let's just take that number, divide it by 100 so we get rid of the percentage, and then we have a decimal, so we have 0.273, and let's times that out, 0.273 times that value, 7.333, and I come out with an answer here of 2.00, and that is 2.002. Look at this. There's my grams of carbon in carbon dioxide, and here was my alternative method to figuring that out. So I thought that might be useful. Take your pick in terms of which you'd rather do. Finally, would this be a reasonable structural formula for this? Is this C2H6? It is. Notice, plus we have an oxygen here. So notice this is my structural formula for this. That's a lone pair of electrons. That's a lone pair of electrons. And there's the structural formula of my compound. All right, everybody, have a great day.